I clicked it, not sure it started.
Yeah.
Okay, it has started.
Okay. Okay, thank you very much and welcome. This is the first training session organized within EDIAQI project related to task 4.3 on interoperable data management. I'm Pier Giorgio Cipriano from DataNext. Together with me, there are also Beatrice Olivari, Martina Forconi, and Luca Giovannini. And we decided to split this training session in two parts. During the first half, that will more or less last 90 minutes, we will introduce, we will have we will start to break the ice with a round table. So we will present ourselves also because we invited other people outside the EDIAQI project, since we would like to extend this module also to other people already working on sensor sourced data. Then we will jump into SensorThings API. So we will present what SensorThings is. And we will see some practical examples of SensorThings API's requests. At more or less at 10:30, we will have a half an hour break. Then we restart at 11 o'clock with some hints regarding an interesting extension of the SensorThings API standard, in particular focused on citizen science. At 11:30, we will introduce Frost, that is a physical implementation of this standard by the Fraunhofer Institute, and we will close with a roundtable with questions and answers. So first of all, who we are, as just mentioned, on behalf of DataNext, the presentations will be held by me, Luca, Martina, and Beatrice. And as also anticipated, apart from EDIAQI partners, we involved some stakeholders, some friends from other projects, in particular from Airbrake project and from usage project. So what we could do in few minutes is a very fast roundtable. Each of you may present himself or herself, name, surname, and organization, and the role within the correspondent project. As I'm not seeing the list of participants, I ask Beatrice, Martina, or Luca to drive a little bit this roundtable. We can do it. We can do this presentation in alphabetic order.
Yes, I can do it.
Okay.
So the first one I see is Alas.
Yeah.
Hi, I'm Hani. Actually, it's my name. I don't know how to change my name here, and my last name is Alas. I am with Tropos, so mainly in work package 3. Yes. Thank you.
Thank you. Then Alessandro Battaglia. Okay.
I have just to activate my microphone because I'm by feet right now, but I can hear you and follow you. I'm Battaglia from Lab Service Analytica, and I'm involved in WP3 and in WP4 mainly as a sensor provider within the scope of the EDIAQI project.
Thank you. Gianna, sorry, I can't read your surname, Caranasio.
Hi, I'm Gianna Caranasio. I'm from Wings, and we are also a sensor provider for the EDIAQI project. There are also my colleagues Vasilis and Michalis from our company in order to participate in this training session. Thank you.
Thank you. Annes? I don't know, maybe I'm not pronouncing it correctly.
And maybe he will
Okay.
present later.
Wait, I see maybe you have the microphone open, but I cannot hear you.
Hello.
Okay, now yeah. And okay, maybe let's just go on to the next one and then we will go back.
Please.
Jose.
Jose typed in the chat his
Okay.
introduction.
Okay, so University of Seville. And then we have Jurgo Preden.
Yes, hello. I'm Jurgo Preden from Thinect, and we are the sensor provider and the cloud solution provider for the Tallinn pilot. And we provide an indoor air quality sensors.
Thank you. Then Francesco Lamura.
Hello, I am Francesco Lamura from Era Luce. I am IT project manager, so I am exploring some solution for providing our cities with smart city solution.
Thank you. Lina.
Good morning. I'm Lina. I'm from Tropos. I'll be joining you today for 1 hour. Unfortunately, I have another meeting then, but Hani will be here, and I'll be taking part in the last 2 sessions. I'm part of the Tropos team. I'm second day back from my maternity leave. Thank you very much for organizing this workshop, and I look very much forward to the results because we want to incorporate a lot of the topics that you're discussing here into deliverable 3.2. So this is highly relevant for us. Thank you very much.
Thank you for joining us. Another Lina.
Hi.
Hi.
I'm Lina Davrenia from Vilnius, and I'm an FTMT and responsible for indoor pollution measurements at school. So actually, I called me here as Vilnius project.
Thank you. Lawrence?
Hello, I'm Lawrence Dilly. I'm from Node Center. We are in Web Package 4, and we're providing the Node data platform.
Thank you. Well, we have Luca, but we already introduced him. Marcello Verona.
Hello, good morning. I'm Marcello Verona. I'm a Society IT Director at Lisbon Council, partner of the EDIAQI project.
Thank you. Maria.
Good morning. I'm Maria from IMRO as part of the EDIAQI project work packages 3 and 4, mostly field work, collecting samples and installing air particle collectors.
Thank you. Marika Ciliberti.
Good morning, everyone. I'm Marika Ciliberti. I'm an information systems analyst and work from Dedagroup. And Deda Next.
Mario Lovrik.
Good morning. Yeah, Mario. I'm from the Institute of Anthropological. I'm from the Institute of Anthropological Research, and yeah, it suffices.
Yeah, that's enough. Thank you. Mikhail?
Good morning. I'm Mikhail Brullos. From Wings ICT. I'm with a team for the sensor providers to EDIAQI.
Thank you. Naomi?
Hello, I'm Naomi Thiru from the Spatial Applications Division Research Group at the KU Leuven from Belgium, and I'm part of the usage project. We are geospatial data experts.
Okay, thank you. Patricia?
Keep
Okay,
going.
she's writing in the
Okay.
chat. And I think I'm missing Vasilis.
Hi, good morning. I'm Vasilis, also working with the Wings team, and we are very happy for this workshop and looking forward to the discussion.
Thank you very much. I think we are done.
Okay, thank you. Thank you very much. So let's start with a very brief introduction. First of all, I just remind you the objective of this first
Sorry,
module.
Giorgio.
Yes.
I think someone was trying to talk. I'm not
Oh,
sure.
sorry. Yeah,
Yeah,
please.
because I think we missed Khalil.
Okay.
Yes.
Sorry.
Hello, I'm a student in the Center of Formation. I'm doing intelligence artificial, and I'm doing internship in the next. Thank you.
Okay.
Thank
thanks.
you.
Okay, I hear someone is joining as well, but I think we need to start. Just reminding the overall objective of the task 4.3 in the EDIAQI project that is entitled interoperability management. The goal is practical and it is the objective is to allow EDIAQI partners, in particular those partners that are in charge of implementing pilots within EDIAQI project, to make their own dynamic data coming from sensors, in particular those related to indoor air quality, fully interoperable. For this reason, we will leverage on existing standards, in particular those standards coming from the geomatic world already defined by the Open Geospatial Consortium, and some of them, as we will see, also ISO standard. This is the first step of 4 slots. Next one will be organized next month in July 21st, and in July we will go in depth into Frost open source solutions. So today the idea is to have a general alignment about the standard itself, but also looking at some initial bullet points regarding Frost implementation. So let's start with introducing Open Geospatial Consortium. As we will speak about standards, in particular SensorThings coming from the Open Geospatial Consortium, let me introduce what OGC is. It's a worldwide consortium made of hundreds of members from private sector as well as from academia and also from public authorities and NGOs. Maybe some of you already had the opportunity or the chance to work or to play with one of the standards that were published by Open Geospatial Consortium, that is the KML. KML is a standard format that is used by Google Earth or Google Maps, and it was introduced by Google. It was submitted by Google, that is a member of OGC, some years ago, and became a standard in few years. We are mentioning this slide because to fully describe what Open Geospatial Consortium is, we took some slides provided by Francesca Noardo from OGC, presented during a webinar that was organized on April the 20 by the Italian National Digital Agency, namely AGID. And so we've stolen, with permission, of course, a few slides from Francesca Noardo presentation. This picture fully describe what OGC is. So it is a community of more than 500 international members. It is divided into more than 45 domain working groups. So working groups with specific topics. At the moment, the OGC adopted 65 standards, and there are already more than 300 products and more than 1,000 implementations that have been certified. So software products and software implementation that provide data or services compliant to OGC standards. One of them, as we will see, is the OGC Sense that was introduced in 2016 or 17 by OGC to allow an interoperable way to interchange dynamic data coming from sensors. But we will see some examples later on today of usage of this standard also with dynamic data not coming from sensors. As OGC is publishing open standards, first of all, let's better understand what a standard is in the perspective of OGC. First, it is an agreed specification of rules and technical guidelines for implementing software interfaces and also data formats or data encodings in order to increase and improve the interoperability of such data. And the focus is on exchanging data, exchanging information. Here, since we are considering standards coming from the geospatial world, we are seeing many times the term geospatial, but geospatial only means to have a spatial dimension of data. Also, data coming from sensors and from IoT network are having in a direct way or indirect way a spatial reference and spatial dimension. It is important that OGC standards are open standards. That means that are freely and readily available. That so OGC standards can be not only accessed and read by everyone, but can be implemented by every software implementer. And more important, like other organizations, also OGC can involve any individual or organization, so everyone can participate. And here there are the definitions adopted by OGC when considering open standards. So, as mentioned before, OGC standards are freely and publicly available. They are available to anyone, so without any discriminatory approach, without any license fee. So unlike ISO or SEN standards that have to be purchased, OGC standards are freely accessible also in terms of economic. They are vendor neutral, so they can be implemented by everyone. And more important, they are data neutral. So all OGC standards are independent from any encoding or type of storage model or format. And of course, they are based on consensus. So all the APIs and standards that we will mention today and also in the following workshops have been published after a long period of negotiation and then agreement on the content of standards. One of the first important standards that are already made available since 2001 is the web map service interface that some years later became also an ISO standard. That means that as ISO standard, it is referenced in some European directives and became mandatory for public administrations to provide and to publish and share maps online in an interoperable way. This is the just the ISO representation of the same standard, and similarly another standard at the beginning that OGC published at the beginning of 2000 is the web feature service that was introduced to allow not only the sharing and publishing of maps in terms of graphical representation, but for accessing in an interoperable way geospatial data. We are mentioning both standards, WMS and WFS, now because we would like to introduce some practical examples of data interoperability with looking at some examples of WMS and WFS application in practice. So I leave the floor to my colleague Martina. I close my screen, the sharing of my screen, and Martina will introduce some practical examples of these two standards that are somehow propedeutic to SensorThings. Please, Martina.
Hi, good morning to everyone. I share my screen. I will talk a little bit about some data interoperability example. First, I introduce QGIS, that is a free and open source desktop geographical information system with which you can also create data, visualize, publish, and you can see data that are in your local PC, but it's important because you can also connect to standard services. The most recent release is the 330, but the suggestion is to install the long-term release that is more stable, and the long-term release now is the 3.10.28. QGIS has a lot of plugins. This is an overview of the interface that later we will see together. There are a menu bar, some toolbar. The main part is the map view, a browse panel, and a layer list that you can add to the map view. A suggestion is to start with a base map, OpenStreetMap. So from the browse panel, you can add the in the XYZ tiles, there is the OpenStreetMap, and then you drag, but we will see later, in the layer list. Pier Giorgio already introduced a little bit of web map services. This is a services available on a server, and you can add to QGIS, but also to other clients, this service, and this is a connection, so you can load the map directly on your QGIS. To do this, you can use the tool Open Data Source Manager, or from the menu layer you can add the layer, but we'll see together. Here we give some WMS example. And then we will see also the web feature services that while the WMS returns an image, with WF services you can get data. So you can have the feature in a different format. The default one is GML, that is in an XML for geographical feature, but you can choose also to have data in JSON or in shapefile or other format. But the main difference is that with WMS you have a map, and with WFS you have data. You can also connect to WFS from Excel, and this is a live connection. So if the data are updated, you will see the updated data. And another thing interesting is the filter. You can filter data using a common query language. That is a language with text-based syntax, so it's easy to add filter. Here I put an example where you can filter for a value in the data, and the example in this case, the output is in GeoJSON, and you can see that with the filter you get the data you are looking for. We put in the slide also some example that we now can see directly in QGIS. When you download QGIS, this is what you see at the beginning. As I suggested before, you can add maybe the OpenStreetMaps in order to have a base map. From the base map, you can move or maybe another plugin that I do not put in the slide, but I can add that I think it's very useful, is the geocoding one, where you can find an address. Maybe we can go to Ferrara and choose the results. You can go down. Another thing that is interesting in this plugin is the possibility also to do the reverse geocoding. So from the plugin with the reverse geocoding, you can click a point on a map and get the address. To add a WMS layer, as I wrote in this layer, you can use this tool, Open Data Source Manager, and choose WMS, WMTS. This one is use tiled images, but the connection is the same for both. Or you can go from the layer menu, add layer, add WMS, is the same window. Then you can create a new connection. You can give a name, Rara, I don't know, I can take one connection from the slide. So maybe this one. Copy. Facciamo T1. Okay. Then you click on the connect button. In this case, you see one layer, but the WMS could also have more layer. Then with double click, you can add on the map. Close. No. Layer.
You can click on add.
Add, yes. Thank you, Giorgio. So, so you see the this layer with our building from the usage project. After you create the connection, you can also use the browser to choose the connection you have created. I have a lot of connection, but Ferrara, this is the one I've just created. The same thing you can do to add a WFS layer. So you do a new connection and you type a name and you type the URL. The URL I put in the slide only to explain a little bit more. So in the slide you have the complete URL that you can also paste in a browser. And this is the request get capabilities. So is the information contained in this WMS. Once you create the connection in QGIS, it's a little bit different, but the same thing. So if we go to edit, no, they take, you can use the syntax generic OWMS that is valid for all the services, so for WMS and WFS. Or you can write here WMS or WFS is a little bit the same. Here I have a project where we have already created the connection. This one. When you open, you can see the release, and then in red, long-term release. In this project, we have already connected to OpenStreetMap, WMS services I say before. So we have the historical cartography. We have the orthophoto from regional Emilia-Romagna server. And we have buildings from usage project. So this is a way to see data coming from different server. Then we added also a WFS connection to buildings, pilot buildings of EDIAQI. Buildings are different color depending on the type of the building. And you can get information on the building using the info button. So in the left, in the right side, you can see information about this particular building. And okay, I think this is most
everything's.
Yes, if you, Martina, if you could remain on the QGIS, on
Yes.
the no, the other
Not this
the
one,
other,
but
yes.
the other one. I have different QGIS
So
open. This one.
why we started from these examples of standard protocols, namely WMS and WFS, because these are practical examples of a client, a unique client, in this case QGIS, connecting to different servers. So in here we are looking at data coming from different providers. The OpenStreetMap base ground is coming from APIs published by OpenStreetMap. The historical map is coming from a server that is, I think, somewhere in Piemonte region, managed by the Regione Piemonte, the regional authority of Piemonte, while the ortho image above is provided by the Regione Emilia-Romagna, and the layer called Fabbricati usage is provided by the municipality of Ferrara. All of these authorities, all of these organizations are using the same standard protocol that is, in this case, a WMS, Web Map Service Interface, to provide their own graphical representation of spatial data in a unique and interoperable way. Similarly, the top layer, pilot building Ferrara, is provided by a geographical server hosted by us, by Dedanext, where we only have pilot buildings that have been selected for the EDIAQI project. So buildings where Lab Service Analytica will install indoor air quality stations. And in this case, we not only have the geographical representation, so the graphical map, but we have data. That means that with this data, we may interact, we may save on our own computer, we may change the legend, we may have further operations more than the operations that are made available with the WMS interface that allow the user only to see and move on a map, identify objects, but without having let's say a local copy of data. In a similar way, as Martina is seeing, we may interconnect data provided by WFS endpoints in this way to other clients like Excel.
This one I do not try before, so allora modifica. I don't know, maybe I have to put no, I don't know. Then we will try to check. Because I have to put the format. Sorry. To connect from WFS from Excel, you have to choose the output format CSV. So in the URL that I can take from here, properties. Copy. The web. And then services. No, because I have to write services WFS. The version I think is not mandatory. Let's try. Allora, qua. Quindi, the type of services. Then the output format. This one. Output format CSV. Okay, connect. No, it doesn't work.
You can try this one. Martina, I paste here another example with air quality data coming from the municipality of Ferrara, provided through a similar WFS endpoint.
Okay, so here the data.
No, carica, yeah.
Carica.
So in this case, Martina connected her own Excel spreadsheet to a WFS endpoint, so an endpoint published by the municipality of Ferrara, a geographical server, providing hourly values of PM2.5 of the last 7 days. Okay. So the last value should correspond to 9 o'clock this morning, more or less. And this is a way to make data interoperable. 8 o'clock this morning. So they are not real time, but near real time. And it is a practical example of how to make data available in an interoperable way. And this is just to anticipate what we will then see with the SensorThings API. That is a new version of interoperable standard for making dynamic data fully interoperable and fully accessible.
And the last example we can see is calling the WFS from the browser with the output format GeoJSON. Here you can see the feature. And in this case, we have more than 1,000 features, and applying filtering option. In this case, we want to see only cycle that are already existing. So I add this filter at the end. Sorry, click in the wrong place. This is with the filter at the end. So in this case, we have less feature because we have applied the filtering in the call, in this one. I think we have seen almost everything.
Okay.
Okay.
Thanks,
so I
Martina.
leave the floor to
Luca, and we will jump in, and we will jump into SensorThings. While Luca is preparing and sharing his screen, just let me highlight the fact that both standards, WFS, as we already saw, but then also SensorThings, as mentioned before, are data format neutral. That means that data can be provided as shown by Martina in different formats. So we can access data in CSV or JSON because the implementation behind allows to provide data in different formats. And we will see now SensorThings. Luca, your microphone is muted.
I am sorry. That's a detail that I always forget. So good morning, everybody. And yes, we will go deeper into the SensorThings module. As Pier Giorgio mentioned earlier, I will use a presentation that was assembled by Francesca Noardo of Open Geospatial Consortium. So thanks to her, she agrees to this use of her material. And I'm skipping the first two slides. Well, the aim was just to point to the fact that SensorThings API is one among many other standards, geographical standards, data exchange standards that OGC manages. And second important thing is that you can have access through the official website of OGC to a more detailed description of the standard, and more importantly to the document that describes the standard in detail, from which I have taken some extracts and that we will discuss now. Okay, so what is this standard, data exchange standard about? The topic is related to the so-called Internet of Things. So this idea of physical objects, connected to sensors that have the ability of measuring information about the real world and transmitting it digitally to the internet, basically. So it's a network of sensors. What is an IoT device? It's a sensor in a broad sense, meaning that it could be an electronic device measuring temperature, but it could be a mechanical device with, of course, an electronic component that then digitalize the signal. The point is that it's a measurement and that it is made available digitally. There's all sorts of sensors. There could be a sensor measuring the getting the signal from a Wi-Fi device, from a cellular phone, as well as a more common sensor for measuring temperature, pressure, or something related to weather. But it could also be a satellite taking collecting information from the Earth's surface. That's again a device that measures something and then transmits the information. And then what's an API? Because we will that's part of the name of the standard, SensorThings API. It's an interface to allow computers to exchange data. So it's a way to automatize the exchange of data between not thought for human beings, but for machines. Of course, a human being can use it also, but that's not the point. So this was to explain the meaning of SensorThings API. So it has to do with Internet of Things that are it's made of sensors, and it's also offering an API to access to this data, to insert new data and access and read data that's already collected. What's the advantage of having a standard in this domain of sensors? Well, again, it's the usual advantage of standards. So instead of having many different implementation, many different pieces of software that do the same thing. So you have vendor A of sensors and vendor B. They have created two different types of sensor. Maybe they even measure the same quantity, temperature, but that's not necessary. But they have different technology, and they develop a software to make the measurements available to whoever has to read them. And they might develop two different softwares to do that, and then to read the data from both of them, you have to develop two different types of connectors to connect to those two different type of software exposing data, and that means that if you had to rely on this situation, you would spend a lot of money if you want to be able to connect to all different sources of data with different technology, with different pieces of software. While with the standard, of course, if all the actors in the ecosystem of sensors agree to work with the standard, so the sensors transmit data or made their data available through the SensorThings API, and whoever collects it in a software that implements the standard, etc., etc. Whoever wants to access to the data just needs to create a way to access to an endpoint that follows that standard. So that has many benefits. It allows a proliferation of new services on top of the data, and of course you can have that anyway. But if you know you can rely on all endpoints or the majority of them having the same standard, it's cheaper to develop services that have a wider base, so you are more incentivized to build actually new services on top of that. And we have already mentioned reduced risk, time, and cost to create a complete cycle of a complete data flow, handling data from sensors. And of course, it simplifies the interaction, the connection between different devices and from a device and application. It simplifies because, again, you just have to think to speak that language, to speak that single standard language. The standard is thought, it's a long-term endeavor. The definition of the standard, it started long ago and it's still in evolution. There were two different versions released, version 1.0 and 1.1. We will have a look at the most recent one, but currently they both just describe the so-called sensing part. So how to manage and retrieve observation that have been taken by sensors, while there is a whole new part, so-called the tasking part, that has to do on how to transmit commands to the devices. There are sensors that can be driven meaning you can tell them how to do some of their measurements. Like you could switch them from one type of measurements to another, or if it's like a camera, you could actually order the camera to move around. So you don't have just the information that's coming, that's measured from the camera, so the video. In some situation, you have to think about also a flow of information that goes from the user to the sensor, and in the case of the camera, that would be the indications on how to move it. So how to task it, and that is a work that is currently being done, and it's not already part of the standard, but it will be. So we will focus on the sensing part, so on how to standardize the flow of data that goes from the sensors to the users, not the other way around. Yeah, exactly. So the time for words is ended. Now let's have a look at charts. It's actually the fun part from my point of view. So the thing that you see here is a schema of how the data are supposed to be, the data coming from sensors are supposed to be organized to be compliant with the standard. It looks like a database schema, and because actually creating tables in a database is one of the easiest way of implementing the standard. What we are talking now about is just theory and abstraction, is a description on how data coming from sensors should be organized. But of course, and this is what a standard is about, it's not about an implementation. Of course, the guidelines provided by a standard should be implementable. They shouldn't describe something that it's impossible to realize in the real world. And of course, there are real implementation of these standards, and we will see them in the following modules. But I just wanted to point out that, of course, one way to physically implement this theoretical organization of data is to create tables in a database that follow this structure. But let's zoom in the structure. In order to make this exploration of this schema well, less tedious and hopefully more clear, we decided to pick an example of what a sensor of an action of a sensor. So let's pretend we have a drone that has been tasked to survey a relief along its route to retrieve its hyperspectral reflectance. So basically, what the electromagnetic spectrum that part of it that is reflected by the ground. So that's what's happening. So how do we describe the how do we organize the data that's coming from this drone if we want to follow the schema described by the SensorThings API standard? Well, we have to put parts of the data into different table. Let me call them like that. And each table describes part of the elements involved that are called entities. So the first entity we want to describe is the so-called thing. Well, a thing, remember we are talking about the Internet of Things, is the object of the physical world that is integrated to the communication network on one side, and it's connected to the sensor on the other side. So in this case, it's the drone. The drone is connected to the hyperspectral sensor, and it's also connected via, I don't know, GPRS, I guess, to the network. So the drone is the element in the physical world that allowed the connection between what's being sensed and its digitalization, and allows that information to be accessible in the network. So in this specific table, you would have to describe the entity drone. So its name, its description, and its additional properties. Then there's the entity location. Well, the location describes the position of the drone in this case. So it describes its route. There are usually two cases, two possible situations related to the location of the thing that's connected to the sensor that's measuring. It could be a thing that is fixed in space, so that can be described just by a single set of coordinates, or it could be, like in this case, a moving thing. So if you want to properly describe its location, you have to provide a sequence, a list of positions in different moments of time. So in case we have a thing that is fixed that has a fixed position, you just need to provide the information about the coordinates in the location entity. And of course, you can provide information about what's the name of that specific location, provide further properties. While if the thing is moving, then you have to provide, again, a list of position and time, and you can do that by the joint use of the table location and historical location. In the table location, you will store as different elements the different positions, and in the table historical location, you will have the opportunity to say each location when was the drone in which moment of time was the drone at any of the locations specified in the table location. So with this simple set of two tables, you can handle both the situation of a stationary thing or of a moving thing. Then finally, of course, you have an entity describing the sensor that does the measurement. And again, here you can provide a name for the sensor, a description, and actually you have an opportunity to describe in detail the sensor, meaning the electronics of it or the components of it, using a specific language that's called sensor ML, sensor markup language, which is not part of the topic of this of this session we are having. But just to tell you that you have a way to describe in very high detail how the sensor works if you want. Of course, is an optional element. And then let's move on. Then you have another entity that's called observed property that as the objective, the aim of describing exactly what it is that the sensor is measuring. So it's a different thing from the sensor. The sensor could be a in the entity sensors describe how the sensor is made, not necessarily what it is measuring, while observed property describes what it is measuring. In this case, the hyperspectral reflectance. The same sensor could be measuring different things like the hyperspectral reflectance and the temperature. But in this case, we are interested on the property hyperspectral reflectance. And then finally, well, not finally, but this is the main element, the so-called data stream. This is the element that connects all the others. So it's actually the table where you described exactly what the time series that you are collecting. So you can see from the schema that this table is connected to almost all the others. So when you know you will be storing a time series about the hyperspectral reflectance of a drone, of that specific drone that is measuring hyperspectral reflectance, then you will create one specific data stream to do that will be connected to this observed property of hyperspectral reflectance, to the sensor that's mounted on that drone, to the drone as a thing, and we shall see in a moment, it's then finally connected to the measurements that the drone is taking. So this table here, this entity data stream, it does not contain the measurements. It's just like the title, the manifest, the metadata for the time series that it's connected to. I hope this is clear. This table, the observation table, instead contains the measurements. The two main attributes of this structure here, of this entity, are the time of the measurement and the value of the measurement. Of course, it's more rich than this. You have a way of specifying if the observation is an instantaneous one, so just one timestamp, one instant in time, or if it covers an interval, so with a start time, a start timestamp, and an end timestamp. You have also a way to store information about different information related to time. You could use this schema also for forecasts. So you have the opportunity to store the information about when the forecast was computed. Of course, when the forecast is about, like I am for making a forecast, computing a forecast now, and that's the time when I'm doing it, about the rain that will fall tomorrow at 10 o'clock tomorrow, and that's another type of time that you are able to store. And there's also a third type of information about time, that it's the so-called valid time, that again for forecast tells you for which span of time the forecast makes sense. So today I'm making a forecast for tomorrow, and that forecast is valid just for 6 hours, because in 6 hours I will be making a new forecast again for tomorrow, but also for the day after tomorrow. So I mean, this is I know I've gone into a very high detail here, and I didn't do that for the other elements, but the point was that I wanted to make it clear that these entities can be described in very high detail, can describe in very high detail the real world situation. They have of course been thought to be able to cover many different situations. And any of these entities have an attribute that's called property that allows to add any extra information to each of the entities that in addition to the standard attributes that were that are mandatory and that are defined in the standard. So it's open to personalization. Finally, there's the so-called feature of interest, that is the feature that's being observed. So the geographical location of what's being measured, which is not in general the same thing as the location of the thing, which is connected to the sensor that it's making the measurements. An example to clarify could be, again, a satellite in orbit around the Earth and taking pictures of the surface of the Earth. Here, the satellite is the thing. Its orbit is the location. It's a location that changes in time, but it's the location of the thing that hosts the sensor, and that's the orbit, while the feature of interest is the surface of the Earth. Okay, so they are two different things in general. And also that's valid also for the drone. The location of the drone, is its route, so somewhere up in the air, while the feature of interest is again the surface down below the drone. Yes. The version 1.1 introduced this improvement, I shall say. That's the idea of multi-data stream. All the structure remains the same, apart from the fact that with multi-data stream, you're able to describe time series, to handle time series, where the value, it's not a scalar value, it's not just a single measurement, but it's a set of measurements. Like, for example, if you had a sensor that at the same time, so at the same instant, measures temperature, pressure, and humidity. And I mean, that's the same sensor. Really, the measurements are done at the same time. Then probably you would want to save the three measurements with a timestamp related to the measurement, with the same timestamp that's related to the three of them, in a multi-data stream, so that you don't have to create three different data stream and replicating the timestamp in each of them. It's just more realistic, and also it saves spaces in a real implementation. And let me give you another example, because I realize that this is probably not real enough. We have worked with sensors that catch the cell phones that are actually looking for Wi-Fi connection. So we catch their beacon looking for Wi-Fi connection, and we catch the IMAC address of the cell phone. Well, not those sensors, the IMAC address of the cell phone, and we measure also the power of the connection. So those are two information that are measured at the same time from the same sensor, and they go together. There's no point in saving them, storing them in two different data streams. You can still do it. There's no, if you need to do it that way, you can treat them as two different data streams, but in general, for example, in this case, it makes sense to have them related one to the other, the two types of measurements, and related to the same timestamp, and altogether be stored in the same time series, so in the same multi-data stream. Okay, don't be scared. This is a copy paste, but the point of this slide is the fact that the standard not just describe the SensorThings API standard, describe basically two things: how the data should be organized, and that in a real world implementation becomes tables in a database. And the second things that it describes is how users, and with that I also include machines that using this standard, how users can access to the data, either to add new data or to retrieve existing one. So that second part as an implementation in the form of an API, so an interface for machines. And of course, the standard describes also the syntax of this API. So how you have to communicate with the API in order to get access to the information you want or to insert new information. And the standard builds on top of OData standard, so it uses a syntax and a set of commands that derives from that. And we are not looking at all of them, but you can do queries, filtering, ordering. You can request counting of elements, and of course you can handle, and I'm talking about the first two, you can decide, you can command over pagination of the output side. So you could say, okay, I'm requesting you this data. I know it's going to be 10,000 elements. Please show me just the first 100, or skip the first 200 and show the rest. So it's a very rich syntax. You have many tool commands to and in detail how to access to the data or how to insert new data. Those are all commands for accessing information. Yes, there's a growing interest and use in the standard, and so much that it's already in a very advanced stage, the definition of an extension, which is called STA plus. STA stands for SensorThings API, and plus for plus, meaning an extension. That's focused on citizen science. We will have a look on that standard too. Not now. Too many schemas in the same presentation can it's too much. But just know that is focused on a use in citizen science, but we will see that it can be used also in other settings. Like it introduces new elements, like the idea of an owner of the data that could be connected to more than one data stream. So you could create basically groups of data streams that are owned by different owners, and that we will see that it's a useful feature to group information, to group sensors and data streams in different groups and label them and be able to access just some of them in the implementation that we are of the SensorThings API that we are setting up for local administrations. This is actually a useful feature because I mean, being able to group sensors, things and data streams into different groups, because with just one implementation of SensorThings API, the municipality or the local administration can collect data from different sources, so from different data sources, yes, and show them separately by source, which sometimes is useful because if some source is related to traffic, some other to air quality, some other to measuring how many people are going through a specific spot in the city, they are not necessarily it's not necessarily readable to have all this information at the same time shown on a map, for example. Might be useful to having a way to separate them. But we shall see that in detail later on. And yes, so I'm to my conclusions. The advantages of this standard is that the data model is flexible. I've tried to provide you examples of that flexibility, the extra parameter properties, so it can be adapted to different cases. The technology is open, so that that eases the interoperability, and the fact that there are multiple implementation of the same standard, so you can choose the one you like most, or you can even implement yours. And the fact that it's based on a standard that's internationally backed, so you know that it was built putting together ideas of many people that are expert on the topic. So it's not created out of a conflict, but out of an agreement and a process that puts together and includes the ideas of all the people involved. It's a very lightweight solution. It doesn't, it is fast, and it's not very much complicated. It creates like 7 tables in a database and a little application that does the API part. It's based on top, it's built on top of a more basic ISO standard on observation, but also on the handling of time and on the handling of API syntax, as I was saying. And it supports very detailed levels of information and quality measures. You can add through the extra properties all the additional information you need also to handle the topic of the quality of the measures. So it's really a complete and rich standard, and at the same time adjustable to many settings. And I think that concludes the presentation. Yes. So
okay.
Thank you for your attention.
Thanks, Luca. While changing the microphone, so before passing the microphone to Beatrice, before the break, we will see with Beatrice some examples of requests of to SensorThings APIs, in particular to the endpoint exposed and made available by the Fraunhofer Institute with near real-time data about air quality. So we will jump into an example of data dealing with air quality. So tightly coupled with the purpose of EDIAQI project, but also with other projects like air brake and usage. And yeah, I leave the floor to Beatrice. And then we will have a break to relax a little bit.
Yeah. Thank you. Okay. So yeah, we are running a little bit late, but my presentation is quite short, so we are okay. I will be talking about the SensorThings API endpoints and how to make simple requests. So first things first, as Luca was saying, there is an API that is available so that users can get the data. And actually this API is built so that it's easier to navigate through it simply using a web browser. What we have to do is to learn how to create these URLs to make the requests we need. So how does it work? We need to know the endpoint of the data that we need, and if we have this endpoint, so this simple URL, we can go to the API landing page where we will see the 7 classes that Luca was presenting before. So basically now we will visualize what Luca was explaining with the data model. For instance, here I have an example. which is about the data from the Fraunhofer Institute. This example is about air quality data. And these data are actually from the European Environmental Agency. So it means that they are data coming from the official stations, official agencies from the different European nations. So these data are official. And here we can find, as you can see, the 7 classes that Luca was talking about. So we have data stream, feature of interest, location, and so on. And we will see later on that if we click on these links, we can see the list of for instance, here, the list of the data stream and so on. But let's see for a moment before some endpoints, because I will leave you here in this slide for, well, actually 5 links. So you can play with this endpoint, and I do think that these data are quite interesting. So especially some of them, I suggest you could try with this to dig into the data. The first one is the BRGM water. So they are data about water. And then we have number 2, which are Fraunhofer statistics. We have demographic statistics, and also we have COVID data. Then the number 3 is the municipality of Ferrara. So in Ferrara, we did a big work, a huge work, putting their data in the standard. So we have many different types of data. As you can see here, air quality. We have bike transit and traffic data. And finally, the example that I will be showing you today, we have this endpoint, which is from the Fraunhofer Institute, as I was saying, and it's about air quality data. So I think it's very interesting, especially for the topic of our project. So how to make a basic navigation.
Beatrice, sorry. Marcello was highlighting that he's seeing your screen completely gray, but I think that it is a problem of Marcello, because I'm correctly seeing your screen.
Yeah, me also. Maybe Marcello, you could get out and get in again.
Yeah, okay. I mean, if you are both seeing it, probably.
Yeah, I don't know if other participants are having the same problem that Marcello mentioned.
I'm also just seeing the links here.
Okay.
So it's okay, I can go on?
Yeah,
just
please.
a second. I have just admitted Marcello back in, so let's hear from him.
Thank you. Now I can see the screen.
Okay,
thank you very much. Good. Sorry for the interruption.
No problem. So a few basic navigation options just to get it started. As I was showing you before, we can put like the endpoint / the class to see a simple list of all the elements of the class. So for instance, here, if we put locations, we will see a list of all the stations that are inside the data. So for instance, here, let's see, this is a JSON. So the first element is in Austria. And this is the name of the station. And we have, for instance, information about the coordinates and so on. So for each station, we have some information, and this is the complete list. So if we scroll down, we will see all the stations. And then there is like this simple tip, which is if you know the ID of the station, you can simply put it in brackets. And for instance, here I put ID 1. So it only shows me the number 1 location. And this is good because it's a first way of filtering. Then this is what Luca was showing. So these are the some simple functions that can be used to make more customized requests. I think probably you can easily understand what some of these means. So for instance, top means that we only take the top n elements of the list. So in my example of before, if we are looking at the list of locations, we can just put top 1 and we will get the number 1 location. So this is exactly what happened before when I filtered on number 1. Then we have skip, which is for paging. So if we put skip equal 10, we will get the elements from the 11th, so the n+1, and on. I mean, I don't even show this because I think it's really easy to understand. Then we have count. So for instance, if we want to count the number of total locations, we see that they are 4,944. And then I think order by. Well, order by, I guess it's also easy to understand. So we have a list of elements and we can order them by any specific attribute we want. So for instance, if we have the locations, maybe we want them in alphabetical order. And so, for instance, here I took the top 3. I mean, 0, 1, 2. And we can see that the first one is A23. The second one is the name AKH. And so they are actually ordered by name. The last one is this one. Then we have filter. So we can basically filter by any attributes we want. For instance, here, okay, this is not really easy to read, I'm sorry. Maybe if I click, we see better. Okay, here I was filtering according to the name. So there is a station that I think it's in Austria, that is called the Stadlau. So if you know the name of the station, you can filter it and you can see the information about it. And another way of filtering, as I was showing you before, if you know the ID, you can use it to filter. Finally, no, not finally actually, but we can use select, because as you were seeing before, when we click on the list, we have a lot of information that maybe we are not interested in. So it may be useful to only get the elements that we want. So for instance, here, if I go on things, maybe I only want the ID and the name, because this could be the only things I'm interested in. And so if I select only those, you see here I only get like one thing, the thing with the ID 1, and I get the ID and the name. So this is more clear. And finally, this time is really finally, we can expand. So basically, like for instance here, if we want to navigate through multiple objects, so we want here, for instance, we want the thing with ID 1, but we want all the data streams that are related to thing 1. So as Luca was saying, one thing can have more than one data streams. So more than one data stream can be linked to it. So if we want the list of data streams that are connected to thing 1, we can use expand. And it will give us a list of all these data streams. Okay. And finally, just to see this data, we can use QGIS, and especially we can, I mean, we have a plugin. We actually built a plugin for QGIS to see this data, to see, I mean, data from SensorThings API endpoints. So here, if we use the plugin, and I connect it to the Fraunhofer Institute, I can see all the data. You can see that they are like the exact number we counted before. And maybe just to simplify, because these are a lot of locations, remember they are all the stations around Europe. So just to make it simpler for QGIS to upload, I will filter according to country code. So let's choose Austria, because it's quite a small country, so maybe it's easier. Let's see. You see, it takes a bit of time. Okay, these are all the locations in Austria, and we can, for instance, click on one of them, And this connects to the data at the endpoint. And we can see that we have informations on the different polluting substances. So we have NO2 and so on. And we can also see their we can filter in the interval of time and check like the information we need. So this is a way to visualize and also to visualize this data on according to the location. This is all from my side. We have just a couple of questions for you before the break.
Yeah, in order to prepare some interaction also during the second slot after the coffee break, we prepared a few slides to questions that you might reply also after the coffee break. So we would like to better understand if you got the difference between the difference and also the linkages between open standards on one end, like the OGC ones and the ISO and SEN on the other, and if you already had the opportunity to use a similar standard, so standards that are similar to the ones that we are talking about, to make your own dynamic data available in an interoperable way. If you have specific questions or comments, you can just start typing them in the chat. So we may take the opportunity of this 30 minutes break for collecting your own comments and questions, not only related to the content of the presentations, but also on slides and materials. So please don't be shy. Do not hesitate to use the chat to interact and to feed some questions. And if okay, we can break for a little bit less than half an hour, so we can reconnect at 11 o'clock on time, and in a few minutes we will start again for the second slot. Okay. I propose to stop the recording.
Okay, I can do it.
I'm already doing it.
Okay.
Okay.